Hi everyone. We are Team 9 from Seoul National University Hospital. We would like to introduce an AI model for intraoperative hypoxemia prediction. Intraoperative hypoxemia is considered one of the most serious risks during anesthesia and surgery because it can cause serious adverse events to patients, such as cardiac arrest, arrhythmia, postoperative infection, and cerebral ischemia. Although a pulse oximetry enables a physician to monitor oxygen saturation during surgery, intraoperative hypoxemia can neither be reliably predicted nor prevented. Thus, more accurate prediction of intraoperative hypoxemia is needed to improve patient care. For our model, we've used VitalDB, a dataset of 6,388 surgical patients from Seoul National University Hospital, composed of intraoperative biosignals and clinical information. For the precise prediction of hypoxemia, we extracted 3,636 cases, which contain patients' age, sex, height, weight, and track values of gas anesthetic, HR, ECO2, RR, FiO2, TV, PEEP, PIP, RFTN20_CE. And we excluded cases with patients under 18-year-old and cases with op duration under 30 minutes. The total number of eligible cases was 3,613. Hypoxemia event is defined as an event with SPO2 under 92 lasting for a minute. Input data is 1 minute length data from 10 minutes ahead of the target event. The input data consists of 8 numeric vital signs, HR, ECO2, RR, FiO2, TV, PEEP, PIP, RFTN20_CE. Each value is recorded per 2 seconds, which means that 1 minute data contains 30 values from each track. To increase target event data, we augmented hypoxemia events by 2 seconds interval. We defined a non-hypoxemia event as an event with SPO2 over 92 lasting for 20 minutes. Like the target event's input data is 1 minute length data from 10 minutes ahead of the target non-event. Target non-event is augmented by 1 minute interval. The number of samples is 750,729. The ratio of target events is 26.7%. Training data and the test data is as follows. The p-value of age, sex, height, weight, hypoxemia events is larger than 0.05, which means that there is not any meaningful difference between training data. The structure of our deep learning model is as follows. We used the CNN model, which adopted the ResNet structure and made it consist of 4 residual blocks. Demographic information of a patient is analyzed after finishing feature extraction of the convolution layer. The results are as follows. The moment hypoxia occurred after 10 minutes, an accuracy of 0.82 and OROX 0.88 were achieved. Hypoxemia after 5 minutes, hypoxia after 15 minutes 0.90, 0.77 is a 10-minute alternative, OPROC of 0.76 is the best. Here is the prediction of hypoxemia after 10 minutes. Intraoperative hypoxemia was a rare situation, which limited obtaining the greater amount of data. Several clinical diagnoses associated with intraoperative hypoxemia are not directly observable and strongly subjective, which is difficult to transit into dataset that we directly can utilize. Our model enables clinicians to proactive intervention before the patients experience hypoxemic events. CNN could incorporate these large amounts of disparate data that extracted from the patient monitor and predict upcoming clinical events. We will continue to add data and evolve the model to create generalized hypoxemia prediction AI model. We will improve the hypoxemia prediction model before 15 minutes, which had a significant drop in performance, to make a more robust prediction algorithm.